Greetings, everyone. My name is Hernani Nascimento from the Meteorology Program of the Federal University of Santa Maria in Brazil, and I would like to welcome everyone to the 9th presentation of the webinar series, Nowcasting Operations and Techniques, Perspectives for South America. This series is supported by the Nowcasting and Mesoscale Research Working Group of the World Weather Research Program of WMO, and we would like to thank everyone who has registered in today's talk. This series consists of webinars that are broadcasted live, always at 18 UTC, usually on the first Friday of each month. But this time we have the webinar being presented exceptionally on the second Friday of April. The presentations are also recorded and made publicly available in the YouTube channel of the Department of Atmospheric Sciences of the University of São Paulo. For these webinars, a number of professionals with long experience in research and operations in nowcasting of convective storms have been carefully selected to give talks. Today's guest speaker is Bruno Ribeiro from Brazil. Bruno's talk will be followed by a Q&A session. And for that, we would like to ask the audience to place your questions in the Google Meet or YouTube chat. We'll read your questions right after the presentation. And please, for those in the Google Meet session, remember to keep your microphone muted. Now I'd like to pass the word to Thiago Biscaro, who is co-chairing the webinar presentation with me, and who will introduce today's guest speaker. So please, Thiago.
Thank you, Hernani. Hello, I'm from Thiago Biscaro from the National Institute for Space Research in Brazil. It's my pleasure to present today's speaker, Bruno Ribeiro. Bruno is currently a postdoc at the University of Albany, where he does research on the predictability of severe storms using convection allowing ensembles. He obtained his bachelor in meteorology at the Federal University of Pelotas in 2012 in Brazil, and a master's degree and a PhD in meteorology at the National Institute for Space Research, INPE, also here in Brazil. His research focuses on several aspects of synoptic and mesoscale meteorology, especially extreme weather events. He worked as an operational meteorologist in thunderstorm forecasting and participated in field campaigns, including the Relâmpago in Argentina and the SOS Chuva in Brazil. He's also involved in initiatives to improve research and operational forecasting of extreme weather in South America. Bruno, thank you for accepting our invitation for this webinar series. The floor is yours.
Okay, thank you, Thiago. I will share my screen. Let me know if you can see that.
Yes, we can.
Yes.
Okay. So yeah, I would like to thank you for the opportunity to be talking in this webinar series. And my talk will cover the Brazilian data set that we are creating of severe weather reports. And I'll show some perspectives, like how can this data set be applied for nowcasting operations. So let's start with some introductions. First, we all know that thunderstorms can pose many threats to life and property, but not all are considered severe. So there are some very strict definitions of what we consider severe weather. And that's important because when we construct these databases, we just want to include what we consider as severe. And then there are some classifications of what people think that is a severe weather. For example, in the United States, they consider severe hail with diameter greater than 2.5 centimeters and wind gusts greater than 65 knots, or a tornado. So any thunderstorm that produces one of these hazards is considered a severe thunderstorm. In Australia, it's a little bit different. They consider hail severe, the hail greater than 2 centimeters, wind gusts greater than 90 kilometers per hour, any tornado, and also they consider heavy rain responsible for flash flooding. So they have some different criteria in different countries, and these are the two that have the most strict criteria. Some other countries, they don't have like a selected number of thresholds. For example, in South America, we don't have like thresholds for what we consider severe. But how do we know that a thunderstorm is severe? So we have, for example, here, there's a radar depiction of a supercell that shows, you see in some areas, very high reflectivity. You can see here the Hook echo, which is associated with a mesocyclone. So we can see these things in a radar imagery but they don't indicate exactly what type of severe is happening. We can infer that, okay, in this high reflectivity area, there's probably heavy rain or hail, but we don't know the size of the hail. Also, if there's a mesocyclone, there can be a tornado or not, so we don't know exactly what's happening at the ground level. The same with satellite imagery. Here is some GLOW16 infrared imagery showing some overshooting tops. We also know that this is related to storms that are developing, but we are just looking at the top of the storm, so we don't know what's happening at the surface. So we need some ground information about what's happening. Here are some examples in Brazil. We have this damage in São Francisco de Paula in 2017, which was likely associated with a tornado. And then we have this very big hail that occurred in Argentina in 2018. It's one of the largest hailstones in the world. And the point here is that we need this information at the ground level to know like exactly what's happening and the intensity of this severe weather, if severe weather is happening. So I will explore some of the existing severe storms database just to give some context. And the first one and the longest one is the one that exists in the United States. They have like many decades with data. And here is one example of the storm reports for one specific date that it was in 31st of March. So there was a severe weather outbreak in parts of the US. And you can see here in red the tornado reports, in green the hail reports, and in blue the wind reports. So there was a very high density of reports in some areas here. Here's an example of how these reports look. So since they are reports, they're probably generally reported by someone that observed the severe weather. So there's a person that was there in the field and observed wind damage, like some trees that fell or some hail. Or in this case, these are tornado reports. So they have the locations where the reports occurred, the latitude, longitude, the time, and then some comments about it, like damage in homes. And you have, this was a high-end EF3 tornado, so it's a very strong tornado, and some other details. So this is what a severe storm report look like in this data set. And this can be used for many applications. One example is shown here, where they have this, what they call convective outlooks that are issued by the Storm Prediction Center. And so they have basically 5 risks, which are shown here in the bottom right. And in this occasion specifically, they issued the level 4, which is a moderate risk in 2 areas. And that's where they expected the higher density and strongest severe weather in this area. So you can see that based on the reports that happened during the event, that the event was pretty well forecasting, particularly in this area, where they were able to capture the area where most of the severe reports occurred. Another application of this severe weather reports database is to create some climatologies. In this case, this is a probability of severe weather within 40 kilometers of a point at a given date. So it goes every 9 or 8 days throughout the year. So you can see in the winter, there are a few reports, and then a few areas of severe weather, and then the probabilities of severe weather start to increase, and then they move north as you have warmer air moving north as the season progresses into the summer. So you can see this type of climatologies using those severe weather reports, and you can assess the risk in each specific location throughout the country. Here's another example that shows the days with at least one report of a severe thunderstorm gust within 25 miles, which is 40 kilometers basically. So you can see areas where you have more days per year with severe weather, for example, here in the southeast. And there are some biases, of course. For example, this is primarily associated to the fact that the southeast has much more trees. So if there's a thunderstorm, it's more likely to cause some tree damage compared to other areas like here in the plains. And this is the same for hail, like the number of days with hail in 1 year. So you can see that in the Central Plains, there are more than 10 days with severe hail within 40 kilometers of a point. And you can see that it's higher likelihood that you get severe hail in this area compared to other areas throughout the country. And this is the same for tornadoes. So in some areas, they have at least 2 or 3 days per year with a tornado on average. But in some other areas, like in the southeast, they have 4 to 5 days with tornado reports within 40 kilometers of a point. So it's very good to get an assessment of how likely is severe weather in one specific area. This is another application of these reports. So here they have the trend in the number of severe weather reports, in this case just for tornadoes. And in black here is the average, and all these other curves are for each year. So on average, we can see that in this year, 2023, there were more reports than average of tornadoes. So it has been more active than a normal year in terms of number of tornadoes in the country. Another data set that exists is the European Severe Weather Database that is not as long as the US database, but it has at least 20 years, I think. They started in the early 2000s. And this is one map showing the reports in the last year from a few days ago. So you can see how the severe weather is distributed throughout the continent. And it's a data set that also has, they report funnel clouds, gust nados, they report ice accumulation, avalanches. So it's more focused on hazards due to any kind of weather than just severe thunderstorms like the US data set. And this is another example. It's a more recent project in Canada where they are trying to document tornadoes that happen in Canada. They are primarily confined to the southern portion of the country. And it's a group of people that when they have a report of a tornado, they will go to the field and they will check if it was a tornado based on the damage and other types of assessments. And in 2018, we decided to start to create a severe storm reports database in Brazil, because in all of South America, the severe weather is pretty frequent. It's one of the hotspots of severe weather in the world, just as North America too. But we don't know if severe storms are more frequent or less frequent in South America. For example, we don't know how often does hail occurs and tornado and etc. So we decided to create this data set in 2018. It's basically it follows the European Severe Weather Database, and I'll show some details about how we do it. Basically, we take reports from social media and newspapers websites. We have these Google alerts that's set up, so it sends us an email every day with all the news that has a given word, like tornado or hail. Of course, they're all in Portuguese. And then we also use TwitterDeck that provides like a list of all the tweets that mention hail or damage by wind or something like this. And then we search for this data, like this is a news article. For example, this is a tweet where it shows some hail. And then we document these in a spreadsheet that I'll show later. So basically, we document hail. So we document all sizes of hail, and we let the user filter these hail reports if he or she wants. And we report the size in centimeters, where we put a 0 if we don't know the size. Sometimes you don't have like a photo like these reports. For example, this in the bottom here is from a news article. And we have damage to a roof caused by hail, probably very large hail, but we don't know exactly the size of the hailstones. So in this case, we don't know the size, but we consider it a report because it caused damage. And then we estimate the size most of the times if you have photos like this, where you can have an idea about the size of the hail. We use this document from the European Severe Storms Laboratory, where they have the hail size compared to an average hand. So for example, if it covers this area of the hand, it's considered like around 7 centimeters. So you use this as a guide to estimate the hail size. We also report wind. All the measured wind gusts over 80 kilometers per hour are counted if there is a weather station that report that. And also damage by wind. So most of the reports are due to damage. We don't have a lot of weather stations in Brazil, so the density is quite low. So most of the reports we get are from damage, like fallen trees or damage to roofs, like in these examples here. And also we don't estimate the wind gusts. So like they do that in the United States. If there is a trained observer that saw the event, this observer can try to estimate the wind gusts, but we don't do that. We just put a 0 because we don't know the wind speed. And also we report tornadoes in this database. We also consider water spouts, that are tornadoes over the water. Sometimes they move towards the land and they can cause some damage. We have some reports like that, but we also report them as tornadoes. And very few tornadoes in our data set were associated with Fujita scale, because we don't have people that go to the field and assess the damage to estimate the intensity of the tornado in most of the cases. So in that, we end up have no intensity associated with them. So regarding the quality control, generally we don't have a time when we have these news articles, for example. So we have to estimate the time using radar or satellite. And we also add an uncertainty associated with the situation, which follows the European dataset strategy. So in the US, they have trained storm spotters that they can report with good accuracy, so they don't have to add this uncertainty to the reports. But in our case, since most reports come from the media, we decided to add this uncertainty to following the European methodology. And for the location, we have latitude and longitude in the data set, and also an uncertainty related to the location of the report. So for example, here's a report in a town that is in gray shading here in the Google Maps view. And we don't know where in the town the report occurred. So we put an uncertainty that covers the entire town. So it was in this latitude and longitude within 3 kilometers of that point. And the uncertainties in the estimated time and location were introduced to let the user decide whether or not to use a specific report. So for example, if the user wants more detailed reports, and some reports have, for example, 1 or 2 hours of uncertainty in terms of the timing, so the user can decide not to use that if he or she wants. And we don't apply any filter to the data, such as removing multiple reports from the same city. We consider them as different reports. And also the user can filter that if wanted. So this is one example. It's basically a spreadsheet. We have in the first column here is the quality control, which is 1, 2, or 3. So 1 is when the report is confirmed by radar or satellite, but we don't have further information about it. 2 is when you have a reliable person that reported it. So it's a person that was trained to report, and he or she knows how to report well. Or when it's an observed wind gust in a weather station. So for example, here we have the gust of 91.8 kilometers per hour in this location. And then we also add the time and the uncertainty in the time in minutes. So we have the date and the time in UTC and the uncertainty. It varies depending on the report and our assessment. We also have the coordinates, latitude, longitude, and the uncertainty in the location. This is the county or the town where it occurred and the state. And this column show the type of event, if it was hail or wind or a tornado. And also this other column shows the intensity of it. So if it was hail, what's the size of hail? For example, here you have hail with size of 3 centimeters. In this location here, there was damage, but we don't know the size, and so on. And if it's wind, we put the wind speed measured by a weather station if we know it. If we don't, we put 0 because we don't know the wind speed, but there was damage. And lastly, there's this last column that's similar to the US methodology, where we have a description of the event, we have the source of the report, news links, detailed damage information if we have, how the time is estimated, if it's estimated by radar or satellite, and how the hail size is estimated if we estimate the hail size. So one example here for this report, and in this line, this is hail with estimated size of 3 centimeters that occurred at 22 UTC plus or minus 10 minutes on 4th April 2020 in this town of Oro, Santa Catarina. And in these coordinates, and the uncertainty in the location is of 3 kilometers. So that's how we interpret this data. So I'll show some statistics about this severe storm report. As I said, we started to document it in 2018. So we have almost 5 years now of reports, which is not enough to build a climatology, but we can have some good idea of the frequency of severe weather and other information that I'll show. So this is the map showing all the reports. So here I'll focus on 4 full years. So it ends on 31st of May 2022 and starts on 1st of June 2018. So we have more than 24,000 reports all over the country. Every state has at least one report, and most of them are wind with 13,000, more than 13,000 reports. and only 1.5% is what we call significant, which is above 100 kilometers per hour. That's because the density of weather stations that can measure the wind is very low in most of the area. For hail, we have more than 10,000 reports. 4.1% are significant, which is more than 5 centimeters in this case. And tornado, we have 226 reports, but it's important to note that it include water spouts. For example, here you have some tornado reports along the Amazon River and many along the coast. So these are water spouts. These ones into the continent, they are mostly tornadoes, and some of them were quite intense. So here's the map for wind. Also, one thing that is important is that most of the reports are south of 20 degrees south. So that's where most of the activity occurs. But we also have some wind reports in other states, including the Northeast, which is relatively dry compared to the other regions. But they still have severe weather too. For hail, we have mostly concentrated south of 20 degrees south, but also we have some hail reports greater than 5 centimeters in latitudes as low as 10 degrees south, which is quite remarkable. And these are the tornado reports, as I said. Many of them are water spouts, but we have some tornadoes, and in particular in this area here in the south, that's where we have most of the more significant tornadoes. This is a comparison of the different seasons. So this is winter in the southern hemisphere, so June, July, and August, and so on. So there is a considerable amount of severe weather in the winter in southern Brazil in particular, and even some of the most intense tornadoes in our data set occur during the winter. I'll show one example later. But the main season for severe weather is the spring. As you can see here, there's a lot of reports in all over this area, including the southeast and the central parts of the country. The summer is mostly associated with wind gusts, sometimes with like summer thunderstorms with low shear. So very large hail is not very common in the summer. It's mostly in the other 3 seasons. And in the fall, we have less reports than in spring, but also there's a decent amount of activity. These are the reports by latitude and intensity. So here's for the wind. So we have the wind speed in the x-axis and the latitude in the y-axis. You can see that most of the strongest wind gusts that were measured by weather stations are also to the south of 20 degrees south. But we have some isolated reports in very low latitudes, in tropical latitudes. And for hail, the same thing. Most of the large hailstones greater than 5 centimeters occur to the south of 20 degrees south. But as I mentioned, there are some isolated cases that occur further to the north. So now I'll show a frequency of severe weather, which is based, so basically I created a grid over this area of the country where severe weather is more common. So this grid has 80 kilometers of space in between the points, and then we calculate the density of reports in each of those grid cells. So if there was one report in one day, that's considered a 1. If there's no report, it's considered a 0, and then we sum the entire year and divide by the number of years that we have. So we end up having this frequency of severe weather. That's basically the number of days per year that has severe weather in this area. So you can see it very high density here near São Paulo, and that's primarily driven by higher population density. So the data set has these problems, of course, because we have places with more people, there will be more reports from those areas. So it's inherent for any severe weather report database. Now looking at severe wind, so wind that cause damage or measure wind greater than 80 kilometers per hour. So again, we have high frequency all over the south, basically south of 20 degrees south. And then we have some higher density where you have most people, but also some higher density here in the western part of the southern Brazil region. And this is only for significant winds, so there are very few reports, just 38 reports in this area. So it's not a lot, but we can get some of those maps too. And most severe reports occur in this area here in the highlands between the Rio Grande do Sul state and Santa Catarina state, where you have some weather stations here that eventually measure wind gusts greater than 100 kilometers per hour. This is for severe hail. Also, we have almost concentrated in the south. And it's interesting to compare with the United States, for example. So of course, we just have 4 years of data here. So it's not a very good comparison with the US since they have decades of data. But we can have some ideas about the frequency of severe weather. For example, hail greater than 2.5 centimeters, which we consider severe, happens 2 to 3 times per year in this area of Santa Catarina here, which is the maximum. And in the US, you have much higher number of days with severe weather. But again, we should be very careful with these types of comparison because the data sets are very different. There is much more people reporting severe weather in the US because they have this network of trained spotters that we don't have in Brazil in such magnitude. We have some trained spotters that I will also show later, but we don't have like a very high density network like they have in the US. And this is for the significantly severe hail that's greater than 5 centimeters. We also see the hotspot in this area here. Also, this is an area with high population density, so the reports might be biased a little bit towards that. And this is the tornado frequency. So again, we have very few reports of tornado in general. So we should be cautious when interpreting those maps. But in the coast, they're primarily water spouts, so they're not considered the same as tornadoes that occur over land that are more intense, generally associated with supercells. But we have this area here where, at least in these 4 years that I'm looking at, we had the most number of tornadoes. And this is compared to one study by Lopez and Oliveira that was published in the Severe Local Storm Conference last year. And they also noticed a hotspot in this area in western part of Santa Catarina state. So it's comparable to our data set, which is good that we have these different methodologies, but confirming this sort of trend. These are some graphics showing the diurnal evolution of the number of reports. So we have the time in UTC here and the number of reports. And we have in black all severe, in blue all wind, and in green all hail. So we can see that they peak at around 18 UTC. So we have the storms that form mainly during the summer, and they peak at the late afternoon time. That's when they produce severe weather. And also for tornadoes, significant wind, and significant hail, we also have this peak for hail in the late afternoon. But we have some events that occur at night in this area, mainly in the southern parts of Brazil. So here I will show some of the records that we have from this data set, some of the most remarkable events. This is an example of the 30 June 2020, which is the highest number of wind reports in one single day. So we have more than 147 reports and 22 with greater than 100 kilometers per hour. This event that occurred on 4th of October 2022 is the largest hailstones that we have, with estimated size around 12 centimeters. They occurred in Silveiras and Teresópolis, which is around 23 degrees south. So they didn't occur like further to the south. They occurred in like subtropical latitudes, which is quite interesting. We have this event that occurred in Joinville in Santa Catarina, which was a major supercell that passed through the city, and since there's a lot of people there, they reported a lot of hail, and we have different size of hail. So this is the size in centimeters. So some areas we had hail with 10 centimeters, 9 centimeters. In other areas, the hail was smaller, like 3 centimeters here and here. So we have this very detailed map in one specific city showing all the reports, which is quite interesting. And only in some events we can do that because we have some events that are very high impact and they occur in cities with very high population density. So we can build this sort of map here. And this is another example of the 14th of August 2020 cases where multiple tornadoes occurred in Santa Catarina state. And this is one case that there was a person that participates in a project, the meteorologist, and he went to the field to track this tornado. And here in red are the places where we have damage by the tornado. And this is the estimated time that the tornado passed by these locations based on the radar. So we can build this sort of like a track of the tornado, which is quite interesting. So I'll show one case that is the 30 June 2020 severe weather outbreak, and I will talk about some of the Nowcasting applications associated with this case and how the data set can be used for nowcasting in this case in particular, but it also applies to other cases. So as I showed previously, this case had the highest number of severe wind reports in one single day. So these are the reports between 12Z of 30 June and 12Z of the 1st of May of 2020. And in blue, these are the wind reports. In green, the hail reports, where you have the yellow dot in the middle. It's because it's hail greater than 4 centimeters. And in the blue, where you have this white dot in the middle, it's because it's wind greater than 100 kilometers per hour. And we also had a tornado in Paraná. This is the temporal evolution of these reports. So we can see how they progress to the east, basically following this quasi-linear convective system that occurred in that day. I guess a lot of people from Brazil remind this event because it was a very high impact event. But also some hail reports occurred further to the north, and a tornado too, so we will investigate this too. So what is impressive about this event is that it was a very large area affected in just a few hours, and there was a lot of reports with measured wind gusts greater than 100 kilometers per hour, which it can definitely cause some damage. So the damage was very widespread throughout this area, primarily in the southern part of Paraná state and in Santa Catarina state. So it was a very high impact event because they had a lot of issues with power outages, for example, and yeah, this was a very high-end event. So the advantage of the data set is that as we move forward with the radar imagery, this is going to show the radar imagery from the Morro da Igreja radar every 30 minutes. So as we go forward, we can see that there is this convective line of storms that is evolving towards the east and is associated with all those wind gusts. But the advantage with having a severe storm database is that we can see that this line is causing severe weather as it moves east. So many of these areas here to the west, they started to report wind damage as the event was unfolding, which means that if there's a forecaster that's looking at this line of storms moving east and is uncertain about the severity of this line, it can look at the severe weather reports and have an assessment of how severe is this line is as it moves to the east. And then it can help issuing a warning or being more specific in a warning to say, well, this is a very dangerous situation, so you should be careful because this line is producing a lot of severe weather reports. And then it moved all the way to the east coast. And this is another example showing the radars in Paraná state. And you can see the line as it moves east. And also there were some discrete storms that formed in this area here in the central part of the state. These are the ones that produce hail, because these lines of storms, they generally don't produce hail, but you would need to have a discrete thunderstorm to produce very large hail and tornadoes most of the time. This is a GO-16 view of this event. The tops of the clouds were not very cold, so they were not very deep, but still this event was able to produce a lot of wind damage. So we can notice through the reports too that the convective mode was different, or like how the convection was organized. So for example, in the northern part, we had discrete supercells that caused large hail and one tornado in this area, in comparison to the south, where we had a quasi-linear convective system or a squall line that produced widespread damaging and a lot of wind gusts and power outages. So also this discrimination of what type of thunderstorm is ongoing in each area can be seen in the severe weather reports. So just look at like this event more in depth. This is the Area 5 reanalysis. These show the most unstable cape in shading and the deep layer shear in these vectors here. So we see that there was not a lot of cape. This was generally below 1,000 joules per kilogram, but the wind shear was very high. And also we had this very strong cyclone to the south. This was the day before the explosive cyclogenesis that occurred along the coast. So the wind was very strong in low levels. This is 850 hectopascal, and this is the standardized anomaly of wind magnitude, which means that the wind speed here was more than 4 standard deviations above normal. So this is a very rare situation based on the magnitude of the wind. And this is the explosive cyclogenesis. This is the standardized anomaly of sea level pressure. It was also very low sea level pressure, lower than 1,000 hectopascals along the coast. So this remarkable cyclogenesis ended up creating this wind corridor here that helped the squall line to be very severe. And here is a sounding that I took in Lajes, Santa Catarina, which is ahead of the line. We can see very strong wind. This is the hot graph. We see very strong wind in low levels, very high storm relative velocity. And the cape was not very high, but still the wind was very strong ahead of this system. So that favored very strong wind gusts. This is another sounding further to the north where those supercells occurred. And we have more thermodynamic instability, but also very strong winds. So that favored strong supercells and a tornado too. So this was the quasi-linear convective system that occurred. This is one of the radar imagery. It was moving at a rate of more than 90 kilometers per hour, so it was very fast. And it also has these discontinuities along the line here that was possibly associated with mesovortices that they generally have 1 to 10 kilometers in diameter, and they can locally enhance wind gusts. So also part of the project that I will talk about soon, we run some simulations for some very high-end events. So this one was run using the MPAS model, and this shows composite reflectivity. So the model was pretty good at depicting the quasi-linear convective system and also some discrete cells here in the Paraná state. But there's spurious convection ahead of the system also limited the intensity of convection along the line. This is a zoom in the eastern part of Santa Catarina state, where you can also see the line formed. It was not as organized as observed, but the model was able to generate that line. And these are the 1 hour maximum wind speed at the lowest model level that show very strong wind gusts. This is in kilometers per hour. So we see a lot of 80 to 100 and even more than that kilometers per hour, which is pretty much what happened. So one application also of this data set is to evaluate these model forecasts, because you can compare like the intensity of the wind in one specific area with what the model was suggesting. So it's quite useful in that respect too. And this is the 850 hectopascal relative vorticity and wind. The relative vorticity is in shaded. And we can see as the line moves, there's this very high vorticity along the line. And here, looking at one specific time, this is at 16 UTC, we see this very high vorticity, and some of these maxima in vorticity probably associated with those mesovortices that were observed in the radar, at least inferred by the radar based on those discontinuities in the line. They are also present here in the model simulation. And also you can see this rear inflow jet that was one of the aspects that helped causing a lot of wind damage in this event. So beyond the severe storm reports database, we have this project that is called the PREVOTS project, which is basically a union of two projects. One of them is the PRETS, that is basically the data set that we have since 2018. And the other project is called REVOT, which is a project from the University of Santa Maria, where they have this project, I guess, more than 10 years. And they basically train storm spotters to report severe weather in an appropriate way. So they train the spotters to know how to report hail, for example, how to report if there's wind damage. So we decided to unite those two projects to have one project that we call PREVOTS, and we have a Twitter account. And it's basically a group of meteorologists whose objective is to improve documentation, research, and forecast of severe thunderstorms in Brazil. So we have several different initiatives. One of them is building this data set of severe weather reports. We also do some outreach. So this is one post that we had where we try to tell people how to report hail appropriately. For example, the right thing to do is to have the hailstone with an object of known size, like a coin or a baseball or whatever. And it's wrong to report hail this way because you don't know the size of the hand of a person, for example, or you don't know the size of this plate or the size of this apple, so we cannot know exactly the size of the hailstone. So we try to do some outreach in this respect to tell people how to report severe weather appropriately. We also have these experimental convective outlooks, and they follow in some ways the methodology of the Storm Prediction Center from the United States. Basically, we have developed these 5 levels of severe potential, where you have this level 0 actually, which is no severe weather expected, and then we have these 4 levels that go from very isolated severe weather to very widespread and high impact severe weather in this level 4. And we issue those forecasts since July of 2020. You can also look at our account on Twitter or Instagram. We post this forecast every day almost. We have 819 forecasts issued so far. And it's the first time that these experimental convective outlooks were tried to be operationalized, I would say, in South America. So we end up doing this almost every day, which is quite new, and we are trying to know if we can do that with the resources we have. So far we had most of the days, we have, of course, the level 1, which is just isolated severe weather, but we had level 3 in 2% of the situations, and we never issued a level 4, which is just for those very, very high impact events. For example, this 30 June 2020 case in Santa Catarina would be one case where we would have to issue a level 4 because it was a very high impact. So we saved this level 4 for the really high impact events. This is the first official convective outlook that we had, which was quite successful. And this is the levels that we forecast for this day. We had basically a meeting in the morning, and then there were like 4 or 5 meteorologists, and we discussed the situation. And then we outlined these levels of where we expected higher density and higher intensity of severe weather reports. And it happened in the area where we were expecting, in this level 3 area, there were a lot of large hail in this green here. And there are also at least 2 tornadoes that occurred in Santa Catarina state. Maybe more, probably there were more, but we don't know for sure. So we only report tornado when we are 100% sure that they were tornadoes. So in some cases, these wind reports might be associated with tornadoes too. This was a quite successful forecast. Here are some images of the tornado damage, thanks to Victor that went to the field. He's part of the project too, and he took some photos of the damage. But the atmosphere is complicated sometimes. So here are some cases where we were not as successful. For example, here we issued a level 2 that was quite wild, but then the storms propagated into this area where we were not even expecting thunderstorms, and there were some reports there. In this case, we expected more severe weather, but there was only like small hail, lower than 2 centimeters in diameter. This area here, we had a big hail outside of the area where we were expecting thunderstorms. So this was really bad. That's what we don't want to happen. In this case, we expected a level 3 here, but there were some reports, which is good, but they were not as widespread as we were expecting. And in this other day here, we had some issues with detecting exactly the area with higher probability of severe weather. So you can see some reports occurred in these areas with level 1 instead of in this area with level 2. And also here we had some reports occurring outside of the level 1 area where we just expected thunderstorms. There were like some very big hail reports there. And also you have the number of times with a given level between this July 2020 and March 2023, which is the period that we had issued forecast so far. So you can see that the level 1 is very common here in the south, primarily in the western part of the south of Brazil, and also in the southern parts of Minas Gerais, where you have a lot of hail reports sometimes. The level 2 is also more common here in the southernmost state, but we also had some level 2 in the other areas, and almost all the region was covered by the level 2, at least in one day. And then the level 3 is only in those areas to the west of the southern part of Brazil. That's where we have those events where we can expect, based on the conditions, very widespread severe weather. So the level 3 was only issued for these areas here to the west. And other initiatives in South America, it's very exciting to see that some other countries are also starting to maintain their severe weather reports database. One example here is Uruguay. They started in 2021. So they have almost 2 years of data. They also report the same thing as us, so hail, wind, and tornadoes. In Paraguay, there's another initiative that started earlier this year. So they also report some severe weather there. And these are all like our initiative. They are from volunteer people that just want to have a data set at some point in the future. So they just dedicate some time to register those severe weather reports. And there is also an initiative ongoing in Argentina, but the Argentinian case, they have association with the Servicio Meteorológico, which is the weather service of Argentina, and they have more support from the institutions in Argentina to build this data set. So it's not just a group of volunteers, but they also have the National Weather Service involved in that. And Uruguay is also looking for some partnerships with the National Institute of Meteorology there. But in Brazil and Paraguay, we still do it just voluntarily. And also have this paper that we are submitting to BAMS, the Bulletin of the American Meteorological Society, where we describe this initiative, and there are people from Brazil, Argentina, Uruguay, Paraguay, and Chile in this initiative. So we are trying to come up with one data set that is standardized, which means that all countries report the same things and they report using the same methodology, so that if someone wants 10 years from now, for example, do a research in severe weather on the La Plata Basin, for example, this person can use this data set. So that's our goal to the future. So conclusions, severe storms reports are a key element in most meteorological services. They are used to validate severe weather forecasts and warnings, to understand the climatology and the recurrence interval of severe storms in the area. So the government can use that to be aware of the areas where the risk is higher, and eventually give some money to those communities so that it can prepare better for severe weather. And there are obviously many research opportunities with having such a data set. And it's very exciting to see that there are some ongoing efforts to build a South American database. So I guess by 2030 and further, we will have a lot of data that researchers and governments can use to improve research and forecasting of severe storms in South America. So that's pretty exciting. Thank you, and we will be glad to have any questions. And there's my contact and also the project Twitter if you want to follow our initiative.
All right. Thank you very much, Bruno, for a very interesting presentation. Lots of interesting information there. And now we open the session for questions. And I'm checking here on the Google Meet chat and also the YouTube chats. Please feel free to write down your questions in either the Google Meet chat or the YouTube chat. I'll start with a question myself. Please, Bruno, could you tell us who actually reports the severe weather occurrences in the US and to whom these occurrences are reported? I mean, just to inform, who is actually reporting and to whom they are reporting.
Yeah, that's a good question. I think I forgot to mention that, but yeah, in the US, you have this big community of storm spotters. They are trained by the National Weather Service from the US to report severe weather, and then they report it to the National Weather Service. So this database in the United States, it's compiled by each National Weather Service office, which are very small regions so they can have very good access to some local people that end up reporting. So basically, yeah, you have these trained spotters and also people that work in the government, like police or people that work in the civil defense. They also learn how to report severe weather, and then they report it to the National Weather Service. And then the National Weather Service is the one that compiles all this information and checks if this information is like associated with a thunderstorm, for example, because sometimes you can have a erroneous report that it's not associated with a thunderstorm. So they have this quality control within the National Weather Service, and then they publish it in the Storm Prediction Center page where you have that list of reports that I showed. So yeah, you have a much more structured network of people that know how to report severe weather, and they report that to the National Weather Service that organize that information. It's very different from our initiatives in South America, where we have just a group of volunteers that are not associated with any weather service, at least in Brazil, and they have to figure out the reports based on media reports, etc. So we have been training some storm spotters, but they are still too few so far. In the future, of course, this number is gonna go up, but so far, yeah, we have to basically search for these reports in the internet, which definitely reduces the quality of those reports and the number of them too.
All right, thanks. I see here a question by Dominique Brunet. What is the latency of the severe weather reports? For nowcasting an ongoing event, it is important to see the reports as soon as possible.
Right, yeah, that's a good question too, because yeah, the problem is that our data set is basically maintained by volunteers. So you basically have 2-3 people that work on the database on a daily basis. So we cannot have the reports very quickly shared with the National Weather Service, for example, because we need to quality control them. What happens in the United States, for example, is that as soon as the report reaches the National Weather Service, they control it for quality, and then they publish it as soon as possible so the other offices can be aware of that severe weather report that occurred. That's not the case in our case. So I was showing one application where we can use the data set in real time, but in fact, what happens nowadays is that we cannot keep up with maintaining the data set in real time. So there is a latency of several days sometimes in these reports. So unfortunately now this cannot be used for nowcasting purposes because of that latency, but we hope that at some point the National Weather Services in those countries, they will take over this activity and they will help maintain this data set so that it can be updated in real time. But now that's not what is happening, unfortunately, because of the few people that are working in this initiative.
All right. Another question and comment by Dominique Brunet. Do you archive the news articles and pictures associated with severe weather reports? From experience, web links you eventually rot, and the evidence associated with the reports found in internet might be lost. I'd like to thank Dominic for these very interesting questions and points there.
Yeah, that's a good point. Yeah, some of in the description section where we describe the report, we always put the link for the newspaper, for example, that had the report where we add more information, but sometimes the link ends up not being maintained, so it will take you to nowhere if you click on it. And what we try to do is to save photos of hail. So most of the big hail, we have photos saved on it, but we don't save other information. There was some initiatives to try to make a PDF of the web page where we are taking the report from, so that we could save those PDFs. But that's ended up not happening because of the lack of people that we have working in the project. We are just too few, and then we just dedicate to maintaining the data set, and we are still trying to get funding for maybe hiring someone that can build this web page where you can save all those PDFs of newspapers, for example, which is definitely very important information. But with the amount of work that we have to do in the data set by itself, we cannot do that so far. But we are hopefully going to get some funding at some point and be able to start to do that. But yeah, that's a very good idea.
All right, thanks. Okay, we have a question by, following the order here, Mateus Nunes. Hello, Bruno. Congratulations for the presentation. In addition to INPE's Nowcasting group, some of other Brazilian centers, Semadem or NMAT, showed some kind of interest or offered some help in the construction and maintenance of the Privots platform. I wonder if this is a question, actually.
Yeah, I think he's asking if any of those institutions demonstrated support. Yeah, they were interested in the data set, but for some bureaucratic reasons, we could not come up with a way to get funding to appropriately pay people to work on the data set, for example, to build a website and other things like that. So unfortunately, we're not able to, like, we had conversations with them, but we were not able to come up with an agreement about how to do it, the best way to do it. But we are looking forward to this kind of initiative where, because I mean, the data set's not supposed to be maintained by volunteers, it's supposed to be maintained by the National Weather Service of each country, because that's how it works in other countries, and that's how you maintain the quality of the data set. But so far, we are still trying to negotiate this kind of initiatives and have enough support from them so that we can maintain these data sets, because sometimes we just share the data, but the centers sometimes they just can't like take one person that works there to work in the data set, so it's quite tricky in that respect. But yeah, we expect that to happen at some point, but so far we still don't have like an agreement with those institutions to maintain the data set, so we are just maintaining it voluntarily.
All right. Another question. Frederico Rudolph, he's congratulating for your presentation, and he's asking how can we implement a storm spotter network in Brazil?
Yeah, that's a good question. I think, yeah, Hernani, he is associated with this project for several years now that trains storm spotters to how to report severe weather. So that's one thing that we have to do, is to make this training available. Maybe one idea we had was to maybe have some of those classes saved on YouTube so that the person can just watch that and then know how to report it. But I think the main thing that should be done is like a very widespread campaign inside the civil defenses and the National Weather Service institutions to like try to come up with a very big network of people that are able to report, because we, as a small project, we cannot have the reach that other institutions can have. So the good thing would be to have those institutions coming up with some sort of campaign where they could like spread the word to a lot of people and train a large number of people, because that's what happened in the United States. You have these storm spotters that are trained every year. There is a course by each National Weather Service office, which are very small regions. So these spotters, they will be trained, and 10 years from now, they will still know how to report that. So with time, you create this huge network of storm spotters, which we should be doing that in South America. But again, since our project is very small and we just focus on the data sets because that's how time that's what time allows us to do so far, we cannot come up with this kind of campaigns. But it would be good if the National Weather Services came up with one agreement to do that in a more widespread way.
Sure. And since what mentioned regarding this initiative on having a storm spotter network, which is actually an outreach project that we have for several years now at here in Santa Maria, and we have now a renewed partnership for this semester with the local Red Cross from Santa Maria, where we will be again providing a course for local people here from Santa Maria who are voluntary people to be trained to become voluntary storm spotters. And we wish to have this type of training going online. We already have some material that we hope to soon make available online as well. So this would be the contribution from this storm spotter network to improve the reports that Bruno so nicely presented during his talk. Let's see, we still have additional questions from, again, Dominique Brunet. Has someone in Brazil or South America started to combine the severe weather reports with radar and model data for training real-time nowcasting algorithms as it's done by Prob Severe?
Yeah, I'm not aware of that. I think nobody's doing that so far. Yeah, since the data set is still like within this project, we still don't have a way to share the data with people, and we are actually following the same idea of the European Severe Weather Database, where we are hoping to have some partnerships where we share the data with some institution, for example, and then we have something back from the institution that helps support the project by helping with control the quality of the reports, or helping us to build like a website, for example. So I think that's one thing that we are looking for now in the project, is to have this partnership so that we can make the data available and then everyone can use it, because so far it's still data that we just use by ourselves because of those agreements that we still don't have with the institutions that we are still trying to come up with those agreements. But yeah, that would be very nice to have this data set being used to train nowcasting algorithms. I know there is some research that is ongoing that use the reports to, for example, compare with reanalysis profiles, and then you can come up with like what's the average profile for severe weather occurring in different parts of the country, for example, and so on. So I think there's a lot of potential in the data set, but we still have to find a way to keep the project going and finding some partnerships with institutions that are willing to really help us, because otherwise we just can't maintain this data set and share the data with people as we would like.
Yeah. Thanks, Bruno, for your answer. I think it is hard to keep the database in a voluntary basis. So yeah, the need for this funding hunt in order to really have people fully dedicated to keep and maintain the database and update the database is pretty important. And I think it is clear for many people the importance of having a high quality database of severe weather reports. And so hopefully you soon get some feedback from people interested in having a collaboration, and then together, being able to get some funding to keep the project. We have a comment here by Diego Ramon. Thank you for the presentation. And I don't know if do you have any additional questions, please, Thiago, could you help me with that?
Yes. We have a question here from Romulo Augusto. Are there any initiatives to take advantage of some objective tool for validating the database? For example, using mesoscale convective storm detection algorithms by satellite or even by radar?
Yeah, that's a good idea. I think they are doing that in Argentina. They don't use those tracking algorithms, but they're also building a website where they are going to put this data set. But the thing is that they have this automatic algorithm that generates a satellite imagery for the report. So when someone is going to verify the report to check the quality of the report, there will already be in the system a satellite imagery or even a radar imagery. But that's not the case. They are just working with satellite. But that helps with the evaluation. But they are not. They just have the imagery. They don't have like a tracking algorithm. But that would be a good idea. As I said, the problem is the time that we spend just maintaining the data set. It's basically me and two other people, and we really have no time to dedicate to other things apart from maintaining the data set. It takes a lot of time. And yeah, we would like to have to apply the data set in other ways, or to have some more automatic tools that can help us with the verification of the reports. But that takes time, and we unfortunately cannot do that now. But hopefully in the future, if we have some funding and some help from other institutions, we will be able to do that. That's a good idea.
Yeah, thanks, Bruno. Rachel is commenting here that her students are using radar to validate the hail database. Rafael sends, are flood events valid as extreme event reports?
Yeah, that's a very good question too. We do not report flash flooding events for two reasons. The first one is that there are too many reports, and we just cannot keep up with doing that with the group that we have, the small group that we have. So just wind, hail, and tornado is enough to keep 3 people at least occupied in this initiative. So we don't do that because we just don't have time. And the second thing is that it's very difficult to define like what we call flash flooding, because sometimes if you have very poor drainage in a city, for example, and you have very weak rain, you're still gonna have some problems like flooding in some streets. So sometimes when you have flash flooding, it's not associated with excessive amounts of rain. And that's difficult because we don't know how to define very objective criteria for what we call flash flooding. So it's a more complicated type of report because of those things, because we have a clear definition of what is a strong wind gust, large hail. The tornado is severe, of course, but we don't have that for flash flooding. So that's one of the main difficulties of that. So these two aspects are the ones that limit us in doing that.
All right, thanks, Bruno. Well, there is, I can see here one interesting question as well. I don't know who asked the question, okay, but if you could talk about the correlation of
That was me.
So it was yourself? Okay, Thiago,
Yes.
so you can ask yourself.
So, Bruno, how can we assess if some area is more prone to severe weather or not just being over-reported because it's a highly populated area? Because we tend to have a correlation between the number of alerts and the people that are living in that region that are able to report those alerts. Is there some way to separate these two things and say, okay, this is an area where we have a large possibility of extreme event?
Yeah, that's a very good point. I think all the severe weather reports database, they have this bias towards cities, for example. You will have more reports of severe if a storm happens over a city, affects a city. So even the data set from the United States has this kind of bias, and it's very difficult to remove that. One way is to doing what I just showed here, which is to have these densities of reports in a specific area. I'll go back to the slide. So with that, we can come up with like the number of reports within a grid box, and then if this grid box is a big city, for example, even if there are multiple reports within this grid box, it will be accounted as one. So we can, in some ways, remove this population density problem, but we, of course, cannot do that fully. As you can see here, as I showed, we have a lot of reports in this area. It's not just because of the metropolitan region of São Paulo, but because we have Campinas here, we have a lot of big cities around. So even if you use this grid box with 40 kilometers, you still have a lot of people around that. So you cannot remove that completely. But it's a way to at least smooth out this problem. But yeah, I don't think there is a perfect way to do it. It's also an issue in the US, in Europe, wherever they have this data set.
Thank you. Hernani? Your mic is closed.
Okay, thanks for reminding us. I was muted. Just related to the last topic, I know that in the US, they face the challenge of how to keep up with the reports coming from North Dakota, South Dakota, where they have an actual reduction in the population. And they see a trend in also it is impacting with the reduced number of reports coming from North, South Dakota in the last years. And that's an impact of population bias, the change in population density. So this is something that will always influence, to some extent, the density of reports that you're getting. Yeah, there are ways around, and I mean to assess that, but it's not always that simple.
Mm-hmm.
Okay, all right. I think that we've addressed all questions. So I would like to thank Bruno for his presentation. I also like to thank everyone who has posted questions and comments, very interesting questions and comments. And again, to thank Thiago and everyone who helped us to organize today's presentation. And to let everybody also know that, so for next month, on May, we will be sending an invitation for the next webinar. So please keep checking your emails for our contact addressing the next webinars. All right. So again, thank you very much, Bruno.
Thank you.
Okay, thanks everyone. So we see you next May. All right. Bye-bye. Thanks.
Richard, está aí?
Raquel tá ali?
Oi.
Oi.
Quem que derruba o negócio aqui?
É o Richard. Mas acho que se a gente derrubar a reunião, derruba.
Sim, o broadcast no YouTube já acabou, né?
Não sei, é o Richard que termina, ou se a gente sai, ele cai, entendeu? A gente sai daqui.
Não, a gente tá lá no YouTube com cara de bobo.
Eu acho que ainda não. Ele que demora um pouco, o Richard tá fazendo 1000 coisas ao mesmo tempo. Ele faz várias reuniões.
Então é só encerrar a chamada, né?
É. Legal, Bruno. Perdi o comecinho, mas o resto eu consegui.
Obrigado pelo convite, foi bom.
Parabéns, Bruno. Obrigado aí. Obrigado, Thiago, Isabelle.
Bem legal, sim.
Ivan, todo mundo que ajudou.
Valeu,
Hoje.
Bruno.
Tá certo.
Okay.
Tchau.
Tá certo. Um
Tchau,
abraço
tchau.
a todos. Obrigado.
Tchau.